No, it's 3, 8. All right, guys, so this is solving exponential equations. Basically, there's only two categories. Okay, so there's only two types. Kind of like logs, so there's only two types. So this first type is if we have the same base. Okay, so this is very similar to the logs. Notice there's only two. Okay, only two bases. I'll show you what I mean by that in just a second. And then the other thing is that there's one per side. Okay. So that's kind of what I mean by b to the x equals b to the power y. Okay, so here, let me show you an example and it'll make more sense. So for example, if I have 3 to the power of 2x minus 9 equal 3 to the 7th. That's what that means. Okay, so same base. They're both 3's. They both have powers. The power doesn't have to be one number. It can be an expression, which is the case here. All this is the power. Okay. So the reason we want it to look like that is because if you can make it look like that, then just like logs, they cancel out. It cancels the base. And so then now they're not a power no more. It's just a regular two-step equation from Algebra 1. Okay. So you're able to solve. I'll go ahead and solve this one. On the rest of the problems, I'm not going to solve after this part unless you need me to, but it's just Algebra 1 after that. Okay, it's just adding the 9 to both sides. What is that? 16, dividing both sides by 2, x equals 8. So I just don't want to eat up our time with the Algebra 1. Okay, but if you need me to, I can solve. Does that make sense, guys, so far? Same base? Okay. So now let me show you just like what happens if it looks like this, what happens if it looks like that. Okay. So here we go. Number 2. So these are like I would say even more common problems. Let's say you had this 5x minus 1 times 5, 3x plus 2 equals 5, 7x plus 16. Okay, so the temptation here would be to cancel the 5's because you're like, oh, they're all the same base. Okay, but it's the same thing as with logs. It doesn't work. There can only be 2 of them, one on each side. So you can't cancel the 5's. So if we can find a way to merge these 2 5's into 1 5, then we could cancel. Okay, and that we can do that with loss of exponents. So here's what I mean. Let me show you the proper form. What do we do with n and m if you're multiplying like this? What do we do with these two? Add them. Okay, that's the rules of exponents. So we add. So that's exactly what we can do here. We can combine the 2 5's for 1 5, and we can add the powers. Okay, again, they're not just one number this time. They're expressions, but it's the same thing. X minus 1, that's the first power, plus the second power, 3x plus 2. I'm still just adding this power plus that power. Okay. And on this side, I still have this. Any questions on this step? Because that's the difference on this step. That's the only difference. Okay. Okay, so you're just combining like terms. So x's plus x's, 1x plus 3x is 4x. Negative 1 plus 2 is plus 1. And there you can cancel the 5's now because you have 2 5's, one on each side. So cancel, cancel. Plus 16. And then after this, once again, it's just Algebra 1. Okay. Move the x's to the left, move your numbers to the right, isolate the x. We're okay, guys, with that? We're okay with the solving, or y'all need me to do that? Is that all right? Okay. Okay, let's keep going. Example 3. So this one is what happens. Okay, so this would be the most common type, I think. So I'm gonna put a little star. This isn't the most usually how they look. 9 4x minus 26 equals. So most of the time they're not as obvious with you, and they don't put them in the same base. But we can rewrite them to have the same base. Okay, so for example, can we rewrite 81 so that it's the 9 to a certain power? 9 squared, right? Because what is 9 squared? 81. So that's usually what you have to do, okay? So I can rewrite this as 9 squared. It's the same. 9 squared is 81. But I just rewrite it. Because if I can rewrite it like this, now they're both 9s. So now they can cancel. Okay, so you just got to play a little bit with the numbers so that they can cancel. So again, algebra 1 after that. Add 26 to both sides, which is 28. Divide both sides by 4, right? Okay. No, we're okay. So the important part of this problem is change the numbers so the bases match. Okay. Question, guys. Okay. Last one of this type, 4. This is very similar to the last one, but it's just a different rule of exponents. I just want to refresh your memory with those. So same type, right? Can I rewrite the 8 as a 2? Of course you can't rewrite the 2 as a 8 because it's bigger, so you have to. So 2, the question would be 2 to what power is the same as 8? 3, okay. Because 2 squared is 4, right? But 2 cubed is 8.
So you can change like the square of it?
This power?
Yeah.
No. So that's what's different about this one. I was about to ask you that. So the difference here is that 4's still there. The thing here, it's like all you did is switch this 8 for that. Right? But that 4's still there, that power, right? So my question to you would be like, so now what happens with those powers, right? What happens with that 3 and that 4? Do they multiply? Do they add? That's the question. So this is the rule for exponents. What you're doing is this. You're really raising a power to a different power. And when you're doing that, you multiply the powers. Okay, so it's going to be 3 times 4. Does it make sense, guys? Does that follow? No? Okay. So it'd be 2 to the x plus 6, and 3 times 4 is 12. Because it's a power to a power. And once again, algebra 1 after that. Okay, you're doing this. You're just doing 2x plus 6. Subtract the 6, divide by 2. Sure, your final answer would be 3. So the reason these problems are important is because you have excess on the powers. Before today, you weren't able to solve problems like that. But since these allow us to bring the powers down, then we can solve them because they're not powers no more. Okay. Question, guys, on these type right now? No? Okay, category 2. So very basic, okay? Easy day. So the difference with these, before I show you like what's the difference, let me give you an example, and then you'll see. So let's say you had 3 to the x equal 80. When you're doing a test or review or whatever, we don't separate them for you and we tell you, hey, this is this kind and this is this kind. So when you see this problem, you're going to think, oh, he said something about the same base, right? And so that's probably what you're going to try first. So the question is, can I rewrite 80 as 3 to a certain power equals 80? Let's think about this. What's 3 squared? 9. And then the next one's 3 cubed. 27. And then 3 to the 4th. Yeah. So 3 times 27, or somebody put it on the calculator, it's okay.
81.
81. So notice we jump over 80. So I can't write it on the same base. Okay. So these problems are like this, where you have b to the power of x, okay, or to the power of whatever, and it's equal to a number or an expression. And so I guess we should put that on here. Can't get same base. Okay, so this is like if you can't get it on the same base, then you do it like this. Okay. Now on this, I'm going to write steps just to help you out. So step 1 is isolate b to the x. And it means get that by itself. Okay, for this problem, it is by itself. So we don't have to do nothing else. Sometimes it's not by itself. Right now it is. If you get it by itself, okay. Now this will be kind of new to you. You probably maybe done it in Algebra 2, but you probably haven't done it a lot. You can take log of both sides. So just like you can multiply both sides by a number, okay, we can take the log of both sides. So that would look like this. Log of 3 to the x, log of 80. Now, the question is, why would we want to do that? Okay, and there's only one single reason why we want to do that. Because if we do that, and this is step 3, then we can use the power rule. Okay. And get, again, that power, that's hard for us to solve a power, but we can bring it down, and then it's not a power no more. Okay, so it becomes just a regular old x. So that's the purpose of doing the log of both sides. Now, so why would we want to do that? Now, think of this. Log of 3, guys, is just a number. Okay, it's some decimal. Log of 80 is just a number. Okay, so you're just doing x times number equals number. And so just algebra 1 again. Okay, so divide both sides by log of 3. Both sides by log of 3. X equals log of 80, just a number, over log of 3, just a number. The only reason we got the yellow calculators this semester, like since we got them, is because of this lesson. Because this is the one thing we can't do without. You have to use your calculator. Okay, so go ahead and plug it just so you can see. Notice they don't have a base, so you can use the one next to the 7. That's the log button. Just do log 80 divided by log 3. But you do need a calculator to compute that. You're going to get some type of decimal. Okay. What is it? 3.98. Okay. Don't worry right now. Don't stress about the rounding. Just put 2 decimal places and we'll be good. Okay. We'll focus on the rounding on word problems, but right now I'm just more worried that you can solve. Everybody okay plugging it in? Okay, let's do a few more just see. That's all there's to these, but let's do a few more so you can see what they look like. Okay, same thing here. I cannot rewrite 18 as a base 5. It's impossible. So now I said isolated. Yes, it's by itself. So you can log. Again, this is really important, so that's why I keep repeating it. The reason you log both sides is because you can that allows you to drop the power down. And why would you want to drop the power down? Because that's where your unknown is, so you can solve for your unknown. Now on this one, I do want to put it in parentheses because I'm multiplying the binomial, both of those, the x and the 1. Okay. So again, log 5 is just a number. Log 18 is just a number. So I'm multiplying this times this, so I can divide this. And then I'm going to move the plus 1 to that side, right? So plus 1 becomes minus 1. And that's your x. X equals that. Okay. Again, just on your calculator, you just divide these and subtract 1. And that'd be your answer. Question right now, guys? Is there something bugging you about this? We're good? Yeah. Okay. So the only thing we can do with these problems to like make them more complicated, and this will be the last one we do, is just add extra steps. That's the only thing that they can complicate this with. And so the part that should stick out to you, okay, is this. The stuff that has the power. That's your b to the x. So is that by itself on the left side? No. Okay, so that's the difference. You have to isolate. So we have to move. You have to move the 9, you have to move the 8. Right? And the 9 goes first because it's subtract. That does matter. Which one you move first. And so we have 8 times 11, 1 minus 4x. What is that? 20? Is it 20? Huh? 32? No. What is that, guys? Is it 32?
Yeah.
32? Okay, divide both sides by 8. Because I'm multiplying by 8. Right, 32 divided by 8 is 4. Again, when you're doing these, you know, you don't know it's not the same kind over and over, right? So we do the same base. So can you rewrite 11 as the base 4? No, so that's why it's not one of those. And that's why you log this side and you log that side. That allows you to bring the power to the front. And so now I have 1 minus 4x. Log 11, log of a number is just a number. Log of 4 is just a number. It's just a decimal. So I divide both sides by log. Now I'm going to tell you how I like to compute. So that's the type into the calculator part. I don't compute right here yet, but you can. Okay, you can go ahead and divide those already. But it's just, it gives you that decimal, but it's fine. So you can divide those two. To move this one, I subtract 1 from both sides. Right, so you can divide those two and then push minus 1. And then lastly, that's multiplying by negative 4. So divide that by negative 4. So you have 2 ways you can do this, okay? But I want you to try just to see that you're getting the right answer. You can plug all this into your calculator. You just have to be good with fancy with your fractions and stuff, okay? Or you could do it in little chunks. So you can divide this 2, subtract 1, and then divide it by negative 4. Okay. But I wanna tell you guys the right answer because last period they were getting different answers. So we need to be sure we can plug it in. What are y'all getting? Huh? Okay, 133? No? 0.33. Okay, that's one answer. Is there other answers we're getting?
So I got
0.10?
Yeah, I got
Negative 0.10? Okay, so that is the issue, right? We're getting different answers. So let me fix that. It's 0.10? Okay, so let me show you. I need to write it down. I forget. So we need to figure out how to plug it in because they don't do us no good if we do all this and then we're plugging it in wrong. Okay, so let's do it. What is the right answer? I think it's going to pop up over here. Okay, I'm just going to do it. I think maybe this is easier. So just doing like a step at a time. So like log 4, make sure you close that parentheses. Divided by log 11, make sure you close that, push enter. And then I'm going to subtract 1 from that, so minus 1. And then I'm going to divide that by negative 4, right? So divided by, is that the only way to plug it in? No. Okay, that's just one way. Okay. Like I said, you can plug in all that stuff in one single step, but you have to know how to play with the fractions and stuff. But that's the right answer. I think maybe what y'all might be doing is maybe this log 4, and then you don't close the parentheses. Maybe that's what's happening. Okay, so you do have to close it. Okay, if you didn't get point 1 and you're not sure here in a second, just ask me and I can check your calculator and I'll tell you why you're not getting that. Okay, guys, but that's all.